Hello everyone, nice to see you all. So welcome to join my class on fundamentals of environmental engineering and science. Okay, so I'm your lecturer, so you can feel free to call me Dr. Wang or just call me Yang because I don't think I'm too much senior than you guys. Okay, so before we talk about the some contents of this class, we'll just go over a brief overview of this class. So mainly it's about why are you taking this class, okay? So some of you might say that this is a prerequisite for a lot of my other classes during on the way of your environmental engineering degree, right? So I think for the civil engineering students, this is also a required class for you guys to take. Okay, so you may say that this is a well-sounded reason, a well-supported reason, but in terms of the science, why are we interested in that? Okay, so there are a lot of things or privileges we have in our daily life that we shouldn't take it for granted. Okay, for example, the access to the clean, potable drinking water. So nowadays we can just go outside to the drinking water station, right? Put our cup there and get the drinkable water. Or at home, some of you might also just turn on the tap and then drink the water from that. Okay, so we can also enjoy the clean, fresh air whenever we go outside to parks or go to the national parks. You can see these clear view and clear sky. This is fresh air. Okay, and I think the air quality in Rolla is also pretty good. So we don't have a lot of those polluted days there. We can also enjoy these very good weather, very good air. And also we have these very clean soils where the great forest can start to grow on them. A lot of plants can live, I would say, happily on this soil here. But we shouldn't take these for granted because they don't happen. These things actually happen at a price. If we don't properly manage our environment, they can easily turn into these results. Okay, so the clean water can get contaminated. Okay, you can see that sometimes, or in very rare cases, when we turn on the tap, the water coming out is brownish. And this is not very old stories. Actually, in 2014, there's a Flint water crisis where people discover a lot of toxic materials in the drinking water. Okay, and also in terms of the air, in more developed countries, let's say in the U.S., in Canada, or in the European countries, the weather or the air indeed look like this. But in a lot of developing countries or in a lot of the major cities, we're observing serious air pollution problems there, where the sky looks very hazy and people with allergies or people with some other diseases are going to be very sensitive to these environments. And further, in terms of the soil, we can easily turn these clean soil into these contaminated soils by just dumping trashes everywhere. And we have to also notice that the trash contains a lot of pollutant species like toxic materials, and they can get leaked into the soil system. It's going to finally harm the plants in the soil system. So we have to do a lot of, or manage a lot of these environmental issues with methods, okay, with some techniques. And we call these techniques, or these techniques belong to the environmental engineering. For example, in water system, we have the water treatment for producing the drinkable water, or potable water. Okay, we have the wastewater treatment to deal with the wastewater that's coming from the industry or coming from the residential areas, okay, to treat them before we release them back into the environment. And for the air, we need to do air pollution control. You can design a lot of devices to get rid of these pollutant species in the air. And in terms of soil, we need to do soil or the solid waste management, right, to pack these trash with specific categories and then further process them with corresponding materials. And you can see that there are a lot of these environmental issues in almost all different areas. So let's think about what are the states of the matter. States of the matter, okay? They can exist in the gas phase, okay? In the liquid phase, or in the solid phase, okay? So you can see that these environmental problems can happen in all of these different phases of the matter. So the environmental engineering tries to solve all of these, or at least try to mitigate these environmental problems, okay? Then you may wonder, why don't we just don't produce all of these pollutants in the beginning? Why don't we just leave without requesting all the sources, all the resources from the environment, or not producing any pollutions at all? There are indeed some people trying to advocate these lifestyles, okay? So this is especially the case for the younger generations. And I'm sure that some of you in the class are also wondering about this. Why can't we just learn in a natural way, like the caveman, okay? So I'm pretty sure that you are quite familiar with this girl here, so Greta Thunberg. So she's a quite active person that's advocating or raising the awareness of these environmental problems that's happening on our Earth, right? So she also made a speech in the United Nations, right, calling on all of the countries to realize these environmental issues and to protect our planet. So during these advocates, or during these activities, people are promoting, or people are proposing that we should ban all the industries, or at least ban all the power plants. And actually, I'm quite happy to see that our school, Missouri S&T, is actually making a positive move here. So as you have noticed, our school have already discommissioned the coal-fired power plant. And actually, we dismantled this chimney from the power plant during the winter break, okay? And instead of using the electricity coming from the coal-fired power plant, we basically started to take the energy from the geothermal that's available in our school, okay? So this is a very active step, actually, to convert our reliance onto the fossil fuel combustion into these renewable sources. But if you take a look at the electricity generation in the United States, okay, so this is the data coming from 2016, which is 3 years ago. And I'll have to say that the pie chart will somewhat look quite similar, although the detailed numbers might not change. Numbers might change a little bit. So what you can find out is that actually coal is still taking around 30% of all of these electricity production, okay? Although there are other resources of natural energy, renewable energies, for example, hydroelectric, biomass, solar, right, wind, geothermal, at all, okay? But we're still strongly relying on the fossil fuel, especially coal combustion. There's no easy way for us to cut all of these coal supplies, cut all of these coal-fired power plants, and then transit into these renewable energies. And in addition, these renewable energies are not as reliable or as stable compared to these coal-fired power plants. For example, the solar energy, okay? So typically during the night, the electricity demand will see a spike because people return to home. We don't have a lot of lighting, right? We don't have the solar radiation to provide you the light there. So basically, the energy demand will spike up overnight. What this means is that we'll need a more electricity production at that time. We also know that the solar energy overnight, basically it's zero, right? There is no way we can produce this solar energy here. Another example is wind. because there's very unstable wind resources at any location. Who knows? There is no way that the wind is always blowing at the same speed over 24 hours over the entire year, right? So we have to consider all of these instabilities in the electricity production. There's still a long way to go for these renewable energies. So that's why they're not even comparable to the coal-fired power plant, because we can almost have endless production of the coal, right? And then we can always run the coal-fired power plant 24 hours over the several years, and we can easily generate a large amount of energy just by a few power plants in the United States. So there's no easy way for us to solve all of these environmental problems by just thinking about cutting all of these energy productions here. Okay. So through this class, you'll start to realize what are the basic principles in designing these environmental engineering devices to solve the problems in water treatment, wastewater treatment, and also air pollution. Okay, so you will realize what is the scale we're talking about and what are the designing principles for these devices. So here is a overview of the course objectives. So you guys, after the completion of this class, you should be able to answer questions. For example, what are the major cycles in the natural environment? What is the human impact upon them? And also, what are the major treatment processes for water, wastewater, air pollution? Okay, and how to design major treatment units used in water, wastewater, and air pollution treatment. So you can see that we're basically water and air pollution are the major problems we're trying to deal with right now. And also how to perform experiments to investigate environmental engineering processes. So as you might have noticed, for this class, we're also having a concurrent experimental section. So you're going to learn about the basic ideas on how to do environmental sampling, or how to design or these environmental devices to deal with the pollution problems. And you should be able to know how to generate laboratory reports, give topical presentations, communicate with others, and also work on solving these problems with mathematical calculations. Okay. Finally, I want you guys to think about and to discuss current environmental topics and pose corresponding engineering solutions. Not just by just saying that, why don't we just cut all of the coal-fired power plants? Okay, so there's no easy way for us to directly transition into another treatment process there. Okay. So in terms of the textbook, we're going to use the Principles of Environmental Engineering and Science, the 3rd edition by Davis and Maston. So I noticed that this textbook already have the 4th edition, but right now is not in a very good binding condition. So when you order them, you're still going to receive them in loose pages. So, and since the 3rd edition is still available on different websites, and you can order the hard copies. And also, it's okay for you guys to use the ebook, because for the exams, they're a closed book, but you can bring 1 page of the notes, or basically the summaries. We can talk about that later. Okay, so you don't have to, you cannot bring your textbook into the exam. And for the textbook, you're going to work on the reading assignments and also work on the homework assignments. Okay. And in terms of the grading, we're going to have 4 exams, so basically 4 quarters of the contents for this class. Okay, so because this is an entry-level environmental engineering class, so we're going to deal with quite many concepts and different treatment systems. Okay, so I don't want you to mix all of these concepts there. So it's probably a better way to take the exams every quarter. So we can focus on certain topics and you can work on problems in these systems here. So for each of this exam is going to cover 15% of the scores. So 4 exams equals to 60%. Okay, the homework covers 20%. The lab write-ups contains 20%. Okay, and since these 3 items add up to 100%, so for the for the class participation, I'm going to evaluate you guys with the in-class quiz, and that's going to give you 10% bonus. Okay, so you have to be in the class to fill in these quiz problems, and you can get the bonus points. And the teaching assistant for this class is going to be Mr. Wei Xinghao. Okay, so he's also a PhD student in my lab. He's going to be the grader and also the lab TA for the class. Okay, so if you have any questions, you can contact me or Wei Xing, and we're happy to help you. So the office hour for this class is going to be 1 hour before the class. Okay, so it's 10 to 11 every Monday and Wednesday, or you can set up appointment if you have other things going on during this period of time. Okay, so you can either contact me, as I said, you can either contact me or contact Wei Xing. Some requirements for the homework exams. So all of these exams must be turned in at the beginning of the lecture. So I'm going to give you the assignments on Wednesday. For that reason, it's due on Wednesday, basically next Wednesday of the class. And it has to be in the form of hard copies. Okay. And for all of the late homeworks, they will have a 40% of the points deducted. Okay. And the assignments should be done on the engineering paper and should be neat, labeled, stapled, and organized. And also for these assignments, I want you to not only calculate the number, you also have to give me or demonstrate the solutions you have. Okay, so it has to be understood, unless you think that the problem is too easy, but you can still come to me and explain how you do that. Okay, just by talking to me. Otherwise, I don't think either me or the TA, Wei Xing, will be able to understand you if you just write up a number there. And also you need to note the answer clearly in the appropriate units. So during this class, because we're dealing with all different systems, so you're going to learn a lot of units there. I want you to note all of these answers in the appropriate units. Okay? And feel free to work together, but do not copy to plagiarize. I don't think I had to mention this more in my class. Okay. So regarding the exams, all the tests are closed book, but you can bring 1 page of your handwritten notes. It can be 2-sided because I think that it's going to be a little bit difficult for me to check your handwritten notes right before the exam. So you can write that 1 page, bring that with you to the exam. Okay, no other materials allowed. And maybe for 1 or 2 of the exams, you can bring your calculator. That means that there are some calculations in the exams. Okay, and in terms of lab and tour reports, so you can see that the lab, there are 2 sections of the lab. Okay, so you can either choose the Wednesday lab or the Thursday lab, and each lab and tour will require a report that's due 1 week after the completion. Okay, so you should follow the required format and turn it in before the next lab class. Okay, and for this class there are additional contact persons. Okay, so I will do my best to solve your problems, and I hope that you can enjoy this class. But if you're having a hard time following the class, or if you really hate me, or you really don't like me, you might say that this professor is really terrible. Or if you like me so much, maybe you like my teaching style or like me explaining things, you can also contact Dr. Joe Birkin. Okay, So he's a chair of the department, and he'll be able to help you with these questions. Okay. So now, before we finally go into the contents, so here is a rough schedule of our class. Okay, for this semester, the class is on Mondays and Wednesdays, and then the labs are on Wednesdays and Thursdays. Okay, so it also labels all the homeworks that's due, and all the lab assignments. It also has the dates for the exams. So unless there are some extreme conditions, the exams are going to be taken on the dates labeled here. So you have to plan your time, schedule your time really well. All right. And I also need to mention in advance that due to some other reasons, there might be that for some time that I'm not in town. So Dr. Dan Arthur will be able to help me cover some of the classes. So we'll find out. Okay. So, as you have noticed, the name of our class is called Fundamentals of Environmental Engineering and Science. Okay, so what is environmental engineering and science? And more specifically, what is environmental engineering and what is environmental engineering, environmental science? So, whenever we talk about science, it's some knowledge, right? Some theories there. So specifically for the environmental science, it is the systemized knowledge that are derived from all different sources, but are related with the natural environment. It can include the atmosphere, right? The land, which means the soil, and also the water and their inhabitants, as differentiated from the built environment. So there are natural environment and the built environment, and we are interested in the natural environment. And in terms of the environmental engineering, so basically the engineering is the applied form of the science. Okay, so we're trying to build some devices to treat certain processes. Okay, so the environmental engineering is the sound engineering thought and practice in the solution of the problems in environmental sanitations. And these problems can include water supplies, wastewater and solid waste, drainage of urban and rural areas, control water, soil, and atmospheric pollution. And it also can relate with the public health. You can control the airborne diseases and also problems related with sanitation. So you can see that the environmental engineering is more targeted at the problems, and we're trying to find engineering solutions by using these science or systemized knowledges here. So in short, you can see that engineering is a profession that applies science and mathematics, right? It applies for all the engineering and science subjects. So then we may wonder, so what happens if we do engineering without science? I mean, no one likes doing these chemistry or physics. What about we do engineering without the science background? So here I have an example, and that's specific for the environmental engineering. Okay. So in 1992, the state of California promulgated some regulations to solve the problem in air pollution. Okay, so what they're proposing is to add these methyl tertiary butyl ether. So we can call them MTBE in short. Okay, so what this chemical does is it raises the octane rating in the combustion engines. So as we know, the combustion engines uses a compression, right? So we have to compress these gasolines into some very small volume. For example, this is our gasoline here. And then by compressing them, we raise the temperature. And then the higher the pressure, when we ignite them, they're going to give more energy, right? So by raising the so actually the octane rating is a number that represents how compressible the gasoline can be, okay? So what this means is the higher the octane rating, the higher the combustion efficiency for the gasoline. So this is very good for air pollution control, because by having by raising the octane rating, that means we can burn the fuels more efficiently. That means we're going to need less fuels, and that's going to generate less air pollutions. Okay, so that's why the state of California give these regulations, or basically to propose that we should add these MTBE into the gasolines, unleaded gasoline, and then we can reduce the consumption of these fossil fuels. Okay, so the EPA, or the US EPA, Environmental Protection Agency, is also quite happy with this. So they approved this and then set up certain programs there. Okay, but nowadays, if you go to California, you're going to see these signs here. Okay, so it says that contains MTBE. So the state of California has determined that the use of this chemical presents a significant risk to the environment. So what happened? Okay, so it was after the these regulations, or people started to study these MTBE, that people start to realize that the MTBE is very soluble. Okay, so it is miscible with water. So what that means is that once it mixes with the water, there's no way we can separate them all from the water. But the MTBE has a disagreeable odor, which means that it's going to be it's going to cause some problems once it gets leaked into the drinkable water system. And also it's a possible carcinogen. So now we start to realize how serious this problem is, right? And then it's also highly recalcitrant, which means that it's very difficult for them to degrade in the natural system. So once they exist or present in the natural system, we cannot get rid of them. So as of the year of 1998, approximately 30% of the gasoline used in the United States contain the MTBE at concentrations about 10%. But we also need to notice that the tanks for storing these MTBE added gasolines, they're likely to corrode and leak, which means that it's likely that these chemicals are going to get leaked onto the ground, leak into the soil system, and finally mix with the water system. Okay. So what we can find out from this, I would say this is a classical failure, right? What we can find out from this failure is that people fail to understand scientifically what this MTBE is going to pose onto the environment, or how harmful that is to our environment, right? We already started to hope that by adding these MTBE, we can solve problems in air pollution. I mean, the intention for doing making these regulations are not bad. We're trying to protect our environment, but it's actually causing more serious environmental problems in other systems. And now you can also find out how these different environmental systems interact with each other, right? So we're dealing with air pollution problem, but it end up pollution problems in the water system, okay? So in this class, we're going to learn about these environmental problems in different systems, and also how they might interact with each other. So first, we're going to touch a little bit on the history of the environmental engineering. Okay, so this is, since this first class is an introduction class. Okay, so we're going to look at how the people from ancient times, or from the old times, deal with the environmental problems here. So first, there are a few examples of the water treatment system. So basically, drinking water, these clean waters, are very important. And you can find out that all of these great civilizations, they originated from rivers, from areas near rivers, right? Because they can directly make use of those unsalted water that's coming either from the mountain or from other lakes or from other resources. Because to sustain ourselves, we have to be able to access these clean waters. So people actually discovered that in Nepal, India, there was a sewer system already in 3750 BC, which means that it's already almost 6,000 years ago. Okay, so there is also a sewer discovered in Baghdad, Iraq, around 2600 BC. And I don't have pictures for these two types of sewers, but there's a sewer that's built in Italy called the Cloaca Maxima, and that started to be built in the year of 600 BC, which means that the sewer system is already 2600 years old. And this is a picture of the sewer system, and it is actually still working. And you actually sometimes can get amazed on how skillful these people, or how thoughtful these people were at that older time, right? And in terms of the modern times for the water treatment, the Chelsea Water Company is the first company that make moves to filter the water from the Thames River in 1829, which is in the United Kingdom. Okay, so you can find out that it was actually because of the Industrial Revolution that started to generate more pollutant into the different like water system or air system, that people realize that we cannot directly withdraw water from the river to drink them. We have to treat these systems, right, to filter out these pollutants from the water so that we can drink it safely. And in the water treatment, there are two icons or pioneers in the environmental engineering that help us realize how important the environmental engineering is in terms of the water quality. So they are John Snow and William Budd. Okay, so they did some pioneering work regarding the association between the contaminated water and disease. So basically, this is a map of the London city. Okay, so what they find out is that the area that has a higher population that are getting diseases is concentrated in certain areas. So they basically sampled water from these areas, and then they realized that it's because of the microbes, for example, the bacteria, different types of bacteria in the water that are causing these diseases. Okay, so they basically raise the awareness of the water quality in the water management or in the water treatment, so that we can start to focus on to raising the quality of these drinkable water. Okay. And in the United States, the first effort was actually made by the State Board of Health in Massachusetts, 1887. Okay, so nowadays for a modern water treatment plant, it's going to contain a lot of steps, quite a few steps, to generate drinkable water. So it can include steps called flocculation and coagulation. So this is for reducing the some chemicals, so they're forming larger particles so that it can settle down in the water. Okay, it has the softening to remove certain metal elements, right? For sedimentation, you can do filtration and disinfection. For example, the filtration, you can still see that nowadays, or we actually use that every day. So I think quite many of you have a water filter at home, right? So there are some great brands, larger brands called the Brita, right? You have those water filters to remove larger particles and also some elements from the water. And you can also have disinfection. So whenever you go to a swimming pool, you can smell the chlorine there. And that is because on our skin there are a lot of bacteria, and we don't want these bacteria to transfer to other people. That might sound a little bit gross there, but by using the chlorine, we can kill these bacteria and also viruses, so that we can ensure the water quality. And this technique is also used in the water treatment plant to remove the bacteria, to remove the microorganisms in the water. Okay, so regarding the history of the wastewater treatment, so actually the wastewater treatment is not dated that old into the BC time. Okay, so it mainly comes with the idea for the water treatment, because from the water treatment we're generating clean drinkable water, and we don't want the wastewater that's generated from industry or residents or stormwater to mix with this drinkable water, right? So the wastewater treatment is mainly targeted at avoiding contamination to the drinking water, okay, before we release these wastewater back into the nature, for example, the lakes or the rivers. And nowadays, the design for the wastewater treatment is also targeted at the environmental protection, because we don't want the wastewater to harm the inhabitants in certain area, right? We want to maintain certain biosphere or biological conditions at certain area. So the first wastewater treatment technique was developed in UK. So it's coming from the Royal Commission on Rivers Pollution, and it started in 1868. And in the United States, the treatment of the sewage was first attempted in Maine, 1872. Okay, and further regarding the history of the air pollution, and so similar to the wastewater treatment, the air pollution is not a very old thing, because if you think about the initial or the early times of the civilization, there are no industries, which means that the air pollution is almost negligible, right? It was because of the Industrial Revolution that creates all of these toxic species, and people have to release them into the atmosphere. So here is a picture showing the pollution problem in the United Kingdom. Okay, in the early time of 1800. Okay, so you can see that there are a lot of stacks, but what's more surprising, or what's more interesting, is that the smoke that's coming from the stacks looks very black, right? I'm not sure if you guys have visited or have driven past certain power plants. What we can normally see is that the smoke that's coming from the stack are normally white. It looks white mainly because there are a lot of water in there, and it's maintained at a high temperature in the flue gas. So by having a lot of water, the water vapor are going to condense. So basically we're forming small clouds there. So that's the reason why it looks white. But from these stacks, they're generating black smokes, which means that there are a lot of unburned fossil fuels or a lot of other particulate matter. So basically, the smoke is going to be very toxic. So as you can see, the air pollution started to be realized during the years of Industrial Revolution, which is approximately from 1800 to 1900. And the first experimental apparatus was built in 1824. And people also designed all different types of techniques. For example, the fabric filters, cyclone collectors, electrostatic precipitators before or close to the 1900. And it is very interesting, or very it is amazing that people are still using these techniques in modern, advanced coal-fired power plants. So basically, the fundamental principles, fundamental science, are still the same. Okay, so here I'm showing a time series in terms of the emission of the atmospheric pollutants in the United States. So from the year of 1940 to 2010. Okay, so it includes the SOx, which is short for sulfur oxides. Okay, it includes sulfur dioxide, sulfur trioxide. Okay, includes the NOx, which is short for nitrogen oxides. VOCs means volatile organic compounds. PM are particulate matters. So these are the suspended particles in the atmosphere. So here you also have the carbon monoxide. Okay, carbon monoxide is also very toxic because it can basically remove the oxygen from the body in the red blood cells, and it's going to cause the serious problems to your body, and also the lead. So if you have a look at the trend of the emissions for these gas pollutants in the atmosphere, you can notice some very interesting features here, right? You see that there is there's a peak for almost all of these gas pollutants, and the peak actually locates at around the year of 1970s, right? So what happened during 1970s? So if you take a look at the economy in the United States, there is no economy crashing, right? There is no crisis in terms of the economy. There is no war, right? So what is causing the reduction of all of these gas pollutants? It was actually because of the establishment of the United States Environmental Protection Agency. Okay, so the President Richard Nixon proposed the establishment of the EPA on July 9th, 1970s, and it began operation on December 2nd, 1970s. Okay, so you can clearly see how the human activities can get impacted by these regulations, and we can easily protect our environment by setting up these regulations or setting up these laws. Okay, to realize the goals in environmental protection, we need to design these regulations or laws, and also we need to design them properly so that they don't harm our economy. So talking about regulations, here is a table that lists the required concentration for these gas pollutants. Okay, so as I've introduced, there are carbon monoxide, nitrogen dioxide. Instead of NOx, they use nitrogen dioxide as a parameter, right? You have ozone, you have sulfur dioxide, and particulate matter, and also lead here. So here on the second column, it shows the required level. Okay, so the concentration have to be lower than this level here, so that the air, which means that the air is going to meet the standards there. And you also have an averaging time for the measurement. For example, the way we measure the air quality is to set up our experiments, or set up our instrument, let it sit outside, for example, over a course of 8 hours. Okay, so it's going to measure the concentration of the carbon monoxide, and it might have different patterns here. Okay, but as long as the average concentration is below 9 ppm, which is also 10 milligram per meter cube, then we will say that the air quality meets the standard. Okay, you can also have different averaging times. For example, if the averaging time is 1 hour, then the level has to be lower than 35 ppm. And you can further think about why we're setting up different standards here. So basically, why the concentration for 1 hour is higher than the average concentration than 8 hours. Okay, you can further think about the background or underlying reason for that. So this is regulations regarding the air qualities, and there are regulations for all types of environments. Okay, so you have regulations in terms of the concentrations for different ionic species, heavy metals in the drinking water, or also in the wastewater, treated wastewater. You can have regulations in terms of the concentrations of these toxic elements in soil systems. And it is because of these regulations and legislations that help us protect the environment. Okay, so then is a brief overview of the course. Okay, so we're going to first learn about the fundamentals of the chemical systems. I'm also going to guide you through the some fundamental chemistry knowledge, so that they will lay the background, or they will help us lay the basic knowledge for designing these treatment systems. So we're going to learn about water resources management system. So that includes the water supply subsystem, which is a water treatment system, and wastewater disposal subsystem, which is the wastewater treatment system. So we can also have the air resource management system that deal with the air pollution control, and also the solid waste management system. So we're also going to learn about the sustainability. So so basically the sustainable development is the condition that meets our current need, but also don't compromise the future needs, okay? So the sustainable development, the sustainable design is a core value that exists in all of the engineering processes, okay? So you may think that, well, the environmental engineering has been developed for such a long time, and it seems that it's a quite complete system now. So why do we still learn that? Okay, it is because there are still a lot of challenges in the environmental systems. Take the most recent water crisis, for example, the Flint water crisis in 2014. So here I included a link that you might be interested to watch, okay? So until now, actually July 2019, the crisis is still not over yet. So for some of the contaminants, the concentration of the contaminants are still very high compared to the standards, okay? And also the air pollution in developing countries is a serious problem, and it is happening right now in countries like China and India. The air quality is even toxic, and people are starting to realize that these toxic air can cause serious neural problems or lead to cancers for the people under these highly polluted environment. So that's why for the homework, or for this first homework, I want you to discuss the hot topics in environmental engineering. So you can focus on any of the topics below, and I have some further requirements regarding how you can form this one-page hot topic discussion. You can talk about the Flint water crisis, talk about global warming. This is a pretty large topic, right? You can talk about the air pollution in developing countries, or the air quality monitoring, and also the Australian fires, right? The fire has been on for almost half a year and is still not put out yet. It's causing a serious environmental damage to the all the different resources there, including the inhabitants. You see those videos about the animals living in those forests, right, during the fire. Okay. So these are the contents for this class, and until now, any questions? So if not, next class we're going to learn about or review some of the fundamental chemistry knowledge that will help you to solve these environmental